generative audio and music.
Our focus is on fast audio synthesis with deep learning models. Intelligent audio generation combines technologies like audio processing, machine learning, and deep neural networks to simulate human audio creation.
To truly democratize this, the model must be lightweight enough to run on a consumer-level CPU, not just research clusters or high-end devices, since the rate of transistor miniaturization has almost halted.
Indeed, audio generation has great application prospects in fields such as media background music and intelligent music intervention. We chose to look at Foley sound synthesis, which is the art of creating sound effects for media.
The mainstream methods for sound generation seem to be generative adversarial networks, GAN, and the diffusion model. Why did your team choose the latter?
We found that the diffusion model is preferred over GANs because it employs a more stable training algorithm called inverse diffusion, which facilitates easier training and avoids mode collapse. This model type, specifically the denoising diffusion implicit model, or DDIM, was chosen for Foley sound synthesis.
Is training models directly on audio waveforms efficient?
No. Training directly on waveforms is computationally expensive and time-consuming due to the high dimensionality of raw audio data. We attempted to convert the audio file into a MEL spectrogram image and then use that image to convert back into audio. This MEL spectrogram format greatly reduces data volume and processing time.
Generative audio modeling is a growing area, but less than 10% of works discussed potential negative impacts. Researchers need to be aware of the potential for misuse by bad actors.
You mentioned specific dangers for speech generation.
Models that can accurately recreate human-sounding voices, sometimes needing only 10 seconds of a speaker's voice for high-quality, realistic text-to-speech audio, have enormous potential for misuse in cases of phishing and fraud. They also pose risks for misinformation or deepfakes.
We should also keep in mind that the energy consumption required to train and generate samples is a concern for all generative audio models, as current research suggests machine learning models are at risk of significantly contributing to climate change.
Algorithmic composition is fundamentally the partial or total automation of music composition using computers. Historically, this field is rooted in techniques related to artificial intelligence that emerged in the 1950s, even drawing inspiration from pre-computer methods like Mozart's dice games.
That seems ancient compared to the generative systems we have now. The whole industry has been confronted with new challenges for sound design since the launch of Suno, which is an AI algorithm dedicated to music creation that became widely available in December 2023. Suno is a generative artificial intelligence GAI program designed to create realistic songs combining vocals and instrumentation or purely instrumental tracks.
It's incredible how rapidly this area is developing. GAI systems are now capable of generating not just rhythms and harmonies, but complex elements like melodic lines.
But there are significant limits. Although the current technology is powerful for targeted tasks, the modulation capabilities and the overall quality of results often remain below professional standards for sophisticated uses, limiting their commercial application outside of things like ambient playlists or background music for broadcast programs.
And we can't ignore the legal storm surrounding generative AI. Suno does not disclose its training dataset, and its legality is disputed. The Recording Industry Association of America, RIAA, filed a lawsuit against Suno and Udio in June 2024, alleging widespread infringement of copyrighted sound recordings and seeking damages up to $150,000 per infringed work.
That points back to the central fear, the replacement of human-created content and the corresponding risk to the remuneration of rights holders. Beyond legal issues, there is an artistic fear, too. There's a risk of musical aesthetic standardization, where AI might encourage repetitive patterns calibrated to appeal to the greatest number, potentially harming musical diversity.
Well, Suno claims its model has been safeguarded against plagiarism and copyright concerns, but even if the legal framework becomes clear, many professionals show skepticism or an attachment to traditional creation practices, fearing a loss of identity if
The impact varies based on the nature of the job. Jobs with a stronger technical execution dimension, like sound engineer or studio technician, are seeing repetitive tasks such as automatic balancing or track cleaning gradually entrusted to algorithms. Automated audio mastering is currently mature technology and partially automates tasks for mastering engineers.
Yet, professions requiring a strong artistic component, like composers and lyricists, rely on intuitive and subjective dimensions that escape current models. In these roles, AI is viewed more as a vector for amplifying the imagination than a substitute for human inspiration.
However, the composer's role is shifting. Image composers, especially for standardized content, must now develop prompt skills to maximize the generative tools. Their added value lies in their ability to supervise, select, and finally edit the AI's proposals, acting as the guarantor of sound quality and artistic intent.
That supervision is vital, especially when you consider elements like voice cloning, which is one of the developments that raises the most ethical and legal issues. Although AI can generate or assist vocal elements, for example, by automatically suggesting complementary vocal harmonies, many artists are uncomfortable with the idea that their voices can be imitated without control.
We must remember that music isn't just a file to download. It represents a whole industry encompassing teachers, musicians, studio engineers, artists, producers and performers, homegrown creators and major music technology companies, festivals, venues, and fans. Music is all of us, and we must protect this economy and allow it to thrive.
I agree completely. The future of music creation depends on us moving beyond unrestricted data mining and focusing on collaborative, transparent, and ethical AI development. The UK is already recognized as a world leader and exporter of quality music, recording innovation, and world-class artists.
And there is a clear window of opportunity for the UK to also be the world leader and exporter of generative AI. Crucially, these two things, AI leadership and creative excellence, do not have to be separate.
That path to leadership must be grounded in respect for creative rights. As the author of 79 granted patents, DAACI is at the forefront of technological innovation. But we must ensure that innovation should not come at the expense of other people's hard work, knowledge, and creativity. That is unacceptable. We must move beyond this.
Our approach provides a compelling blueprint for how AI can respect, protect, and elevate human creativity, setting a new standard for ethical technological innovation in music. By prioritizing transparency, creative attribution, and human agency, we show that AI can be a powerful ally to human artistic expression.
Our system actively tracks human creative input across 5 consecutive stages: intent briefing, structure formation, chord schematization, music texturization, and audio production, to ensure that the composition reflects the user's creative vision.